Hello everyone, this is N Poornima Deepthi working as an assistant professor in the Department of Electronics and Communication at MLR Institute of Technology. Today's topic is 8251 USART interfacing with 8086 microprocessor. As this video is a part of series MICROPROCESSOR and MICROCONTROLLERS. The overview of today's presentation is what is USART, Universal Synchronous Asynchronous Receiver and Transmitter, why we need this USART to interface with 8086 microprocessor, and what is the parallel and serial communications which we are using in this processor and in the part of 8251 USART. So what is the architecture of 8251, what is the pin description of 8251, how to interface a 8251 device with 8086 microprocessors. Why we need 8251 USART, Universal Synchronous and Asynchronous Receiver Transmitter. What is the purpose of interfacing 8251 USART to 8086? As any peripheral devices which want to communicate with 8086, if that particular peripheral device is of serial communication, it will send the data one bit by bit in serial communication format. Then the corresponding 8086 doesn't have the serial communication, so it will always work as in the parallel communication. Now, to communicate the data which is peripheral device want to send to 8086, there must be another chip which will convert the serial data which is coming from the peripheral devices to microprocessor 8086. So this is 8251 which takes the input from the peripheral devices as the serial data and it transmits the parallel data to 8086. If the 8086 want to write the output to the external peripheral devices, then again 8086 will send the parallel data through to 8251 and 8251 converts this parallel data and to the serially streamed serial data and will get back to the peripheral devices. That's why we need 8251 USART to communicate between 8086 and other peripheral devices. And again, 8251 can support both synchronous communication and asynchronous communication. So here, coming to the communication. So which communication is better? Whether parallel communication is better or serial communication is better? It totally depends upon the application where we are using this communication. If we want to transmit the data simultaneously, like we need to transmit the data more fast, then we can go for parallel communication. Because if I want to transmit 8 bits of data at same time, so then you can transmit the data over using parallel communication. Here, how many bits of data you want to send, that many bits of transmitters are here I want to send 8 bits of data parallelly. So here 8 transmitters need to have transmitter 0 to transmitter 7, and to receive the 8 transmitted bits we need to have receiver R0 to R7. So here the components cost may be high when compared to the serial communication, and it requires multiple wires. On single bit it requires single wire to transmit and receive the data. So here first shortest distance we will go for parallel communication, and for the longest distance most probably we will prefer serial communication. One of the example of parallel communication is data bus within a computer. Like here 8086 is a 16-bit processor. So 16-bit data buses. So at a time it can transmit 16 bits of data within the CPU. So coming to the serial communication. In serial communication, the data will be transmitted bit by bit. After sending the first bit, the second will be transferred. And after receiving the second bit, the third bit will be transferred. Like this, the data will be transmitted bit by bit. To transmit n number of bits, it will require one transmitter or one receiver, or you can say like one bus. Wire is enough to transmit the n number of bits at it. But here at a time only one bit can be transmitted. So for sure, if you want to transmit the data fast, then you can prefer parallel communication. If you want to transmit the data with cost effective and for long distances, we will most probably select serial communication for this process, and requires fewer wires here. So one of the example is data transmission over a telephone line. So here only one wire will be there. Data will be transmitted over serial communication in telephone and while using USB also. Next, coming to the architecture of 8251. So here, this is the architecture of 8251 USART, Universal Synchronous and Asynchronous Receiver Transmitter. Here the main block, the first one is data bus buffer, which transmits or receives the data. Here this data will be, this D0 to D7 data lines will be synchronized with the system bus of 8086 microprocessor. And here this is the unit read or write control logic. So it will send whether the control word is have been sending or whether the status word is sending, or the data might read or write when with the 8086 microprocessor and other peripheral devices. So coming to the modem control, here this modem control will be used to synchronize with the 8086 for handshaking or synchronization to transmit or receive the data, whether the transmitter is ready, whether the data set is ready or the command is ready. So to synchronize with the 8086 microprocessor. So here transmit buffer, this buffer is used to convert the parallel data of 8086 to the serial, and it will transmit from 8086 to the other peripheral devices. Here there are transmit control, where these 3 pins will be used. This one is the clock pin. With how much baud rate usually the data need to be transmitted. And these 2 are the signals which indicates whether the transmitter is ready to transmit the data or transmitter is empty. So here this is the receive buffer, which is used to convert the serial data coming from the peripheral devices and convert it into the parallel data and giving to the 8086 microprocessor. This is the input which we are reading from the external devices. And here receive control will be there to receive the data, whether the data is a synchronous. If the data is synchronous data, then it will detects, this pin will detect the synchronous bit of that particular data. If the data is the asynchronous mode, then it will detect the break point of that particular asynchronous mode data. So here the data bus D0 to D7 data bus will be synchronized with the system bus of 8086, whether it is transmitting or data or receiving the data, or the control word is going, or the status of 8086 is displayed. So here this will transmit the data over the 8086. So next one is read or write control logic. This control logic will decide whether the data is moving or going from 8086 to other peripheral devices through 8251, or the input is getting from the peripheral devices to the 8086. It totally depends upon the control chip. CS is a chip select pin, and here this is control word or data word. Here the control word means it is having control register word or status. It can transmit status or control, and D means data. So here read operation is being performed or write operation. Read means input is getting from the peripheral devices to the 8086 microprocessor. Write operation is the output is going from the 8086 to the other peripheral devices. So if the chip select, as it is a negative logic pin as we are seeing here. So if 1, then the 8251 will be in the off condition. There is nothing, the data will not be sent here and there. So if the chip select is 0, then it totally depends upon the C by D bar. So if C is 0, then means the data will be moving or receiving. So here RD bar, so the data will read. So reading means it will get the data from 8251 to other peripheral devices to 8086 microprocessor. And the chip select is 0 if C by D bar means data will be selected. If WR bar is 0, then write operation will be done. So 8086 is writing the output to 82 other peripheral devices using 8251 USART. So here if the chip select always be the 0, then only the operation will be done. Here if C by D bar is 1, then the status word will be read from the internal registers of 8251 to 8086 microprocessor if RD bar is 0. If C by D bar, again control word will be used, and if WR bar. So write operation will be the control word from 8086 will be write to the 8251 USART. So this is the operation. So the read or write control logic will always decides whether the data is moving from 8086 to 8251 or the control and status words is moving from or to 8086 to 8251 USART. So coming to the next one, modem control. So modem control is the device which converts this analog signals to the digital signals and vice versa. And it will be always used to communicate with the CPU to other lines or other cables. So here there will be the 4 pins will be there for this communication. DSR is data set is ready. This pin indicates this is a negative logic pin. As this pin, if it is 0, then this pin is low, then it is saying that it indicates that the data set is ready to receive the data. So data set is ready to receive or transmit the data. To the data set which we are receiving or transmitting will be ready. So here DTR is data terminal ready. Yes, data terminal is ready to receive or to transmit the data. CTS is clear transmit set. Clear transmit set. So RTS is receive transmit set. So here next one is transmit buffer. So transmit buffer is used to convert the data coming from the 8086 as it is a parallel data. So this parallel data will be converted to the serial data and will be transmitted to the other peripheral devices. So this transmit buffer temporarily stores parallel data bytes and it will transmit the serial transmission. So TXD, transmit data output. TXD bar is used to transmit the data output. Here other pins will be there. TXC. So it will decide, it is the clock frequency, it will decide with how much baud rate usually the data will be transmitted. So input, this is the input which we are giving to the 8251 USART. So depends upon the clock frequency, it will transmit the data over to the peripheral devices using 8251. Here TXRDY and TXNT, it indicates TXRDY indicates that transmitter ready output. So transmitter is ready to transmit the data. So TXMT indicates that the transmitter is empty. So the register, the data will not be there in the particular register. So you can reload the data to transmit that. So it is indicating that the transmit empty output. So coming to the receive buffer. So it is receiving the data from the external devices to the 8086 microprocessor. So here RxD, which will receive, it indicates the data input, it is receiving the data, and RxRDY, so receiver is ready to receive the data. RxC, so it is the clock frequency with how much baud rate the receiver need to receive the data from the other devices. So it's in this receiving option there is 2 phases because 8251 USART will support synchronous and asynchronous mode. In synchronous mode, the data, the baud rate will always equals to RxC, clock frequency. So in asynchronous mode, the baud rate is equals to either 1 or 1 by 16 or 1 by 64 of RxC, clock frequency. So in synchronous mode, the baud rate is always equals or parallel to RxC, the clock frequency which we are getting into the 8251. So in asynchronous mode, the baud rate will always be equals to the fractions 1 or 1 by 16 or 1 by 64 of RxC. So whatever the input frequency we have applied, the baud rate while we are using asynchronous mode be equals to same RxT, or it will be equals to 1 by 16 of RxC, or it will be equal to 1 by 64 of RxC. It will totally depends upon the mode which we are using. And here another pin is there which is important. Synchronous detector and breakpoint detector. Synchronous detector and breakpoint detector. Here in the synchronous mode, this pin will detect the sync bits. synchronous bits. In asynchronous mode, it will detect the breakpoint of asynchronous data. So it will be used to detect the synchronous bits of synchronous transmission and breakpoint bits of asynchronous transmission. So coming to the pin configuration of 8251, as this is a 28 pin dual inline package. Here, so D0, D1, D2, D3, D4, D5, D6, D7. These are the 8 data buffer lines, D0 to D7, which is used to synchronize with the system bus of 8086, RxD receive and TXD transmit. So in TXD there will be 2 lines, transmitter ready to and transmitter is empty. In RxD, Rx ready, receiver is ready, and synchronous detector and breakpoint detector is ready. So in modem controls, CTS bar, RTS bar, DTR, DS bar. In receiver, RXC, VCC and ground will be there, and reset pin. So while we are using reset in 8251, the internal registers of 8251, the command word, status word, everything will get back to its normal positions like 0. TXC transmitter is ready. So write and chip select, control or data, read one. So these all are the pins which is used in 8251 USART. So coming to the interfacing of 8251 with 8086, as I told you that the D0 to D7 of 8251 will be synchronized with the system bus D8 to D15. The higher byte of the system bus will be synchronized with the D0 to D7 data buffer of 8251. So the chip selector will be decided by the address lines A7, A2 and A0 by using 7430 NAND gate. So here control and data word will be given to the A1 of 80 address lines of 8086, and input output read, input output write will be connected to the RD and WR byte. Reset will be linked to the reset. Clock output of 8086 will be given as the input to the clock of 8251 controller. So 8251 USART. Here this RS232 is a standard transmitter, standard communication standards. So here this driver 1488 driver will be transmitting the parallel data of 8086 to serial data. So RS232 is a standard universal bus which transmits serial data. So standard one. So here this receiver 1489 will take the serial input and convert it into the parallel output. So this is used for transmission and this is used for reception of the data. So RXC and TXC will be given as the frequency, so which will decides the clock frequency, the baud rate, whether for which baud rate we need to transmit the data or to receive the data. So until now I have discussed why we are using 8251 USART to interface with 8086 microprocessor, and what is the parallel and serial communication and architecture and pin configuration of 8251 USART. Thank you.